Hello and welcome to another video. In this video, we're going to be continuing on with the TypeScript line 75, and we're going to be doing house robber. So in this problem, you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed, and if you rob a house, you can't rob adjacent houses. You have to skip a house. So in this example, for example, if you rob this house over here, you can't rob this house or this house. And so they ask for what's the maximum amount of money you can rob without alerting the police, and you alert the police if you rob consecutive houses. So in this case, it would be 3 and 1. That would give you 4 because you can't rob consecutive houses. So you can either rob 3 and 1 or 2 and 1, 3 and 1's more. And in the second one, you want to rob 2, 9, and 1, right? Still not robbing consecutive houses. So the question is, how do you do this problem? And I'm not going to go over the like space optimized bottom-up DP. If you want to see that kind of stuff, I don't want to make like a 20-minute video on an easy problem. If you want to see that kind of stuff, you can check out my house robber problem in Python, where I do go super in-depth into that. So I don't want to like repeat myself there. So what we're going to actually focus on is just one of the decent approaches on doing it, which is going to be DP. And this is like the problem that you want to know to use DP. So we're going to go over the DP solution here. So let's take this array. And essentially, if we pick to rob a house, right, like let's say we pick to rob this house, we can't rob this house. So let's just try to figure out what states we need for the DP and like what kind of our thought process would be, right? So DP, as always, needs 3 things, right? It needs states, base case, not a base case, and a recursive case. So for the states, like what do we need to keep track of in here? Well, we only really need to know the index we're on, right? Because we can just figure out where to jump to, and I'll kind of show you how to do that. So essentially for the states, we only need the current index we're on. Let's call it the index. And the base case is what? The base case is pretty much we are out of bounds, right? And what should we return if we're out of bounds? Well, that one's pretty straightforward. We just want to be returning 0 because we're essentially returning how much we're robbing. So like once we're out of bounds, once we're like done with everything, there's nothing else to rob. So we just want to return 0. And then what's the recursive case? So at each stop, we have 2 options, right? We can either rob the house or don't rob the house. And where should we go if we do either one, right? And like, how do we figure out what to do here? Well, if we rob the house, let's say we rob this house over here, right? Say we rob here. I don't know why it's doing that. It's kind of annoying. Okay. Oh, it's okay. It's because I'm doing the letter. Okay, there we go. So let's say we rob this house. Where do we want to go? Well, we can't go here, right? So we have to skip a house. So if we rob a house, we have to move up 2 indices. So let's write that. So we have to go to, and like, what are we getting? So we are getting the value of that house plus DP of index plus 2, right? We did rob, and now we have to move up 2. So we can just manually move up 2 indices, and we can just skip the houses we're not allowed to go to keep track of less states. Because otherwise, we'd go over here, and then we'd have to have some kind of value of like, are we allowed to rob it or not? And that just wastes space, right? So instead of doing that, we can just skip the place we're not allowed to go to and just go to the right index all the time. And then wherever we go, we can always rob it. So if we rob the house, it's the value of the house plus DP of index plus 2, right? So like if we rob here, we would move over here. Now, what if we don't rob the house? So if we don't rob the house, obviously we don't get the value of the house, right? But where do we go? Well, that one is pretty straightforward. We just go to the next house, right? So if we don't rob this house, then we can just go straight away over here and try to rob that one, right? So these are our two choices. Rob the house or don't rob the house. Now, are we adding them? Are we maximizing what's going on here? Well, you can actually only do one of these, right? You can't rob and not rob the house, right? So what you want to do is actually you want to compute both of them, and then you just want to get the maximum here. So at whatever you're at, you just want to say like, okay, what's the value of robbing and what's the value of not robbing, and maximize that and return that. And then obviously you want to have some caching. So we'll just add caching as well for DP because you can get to the same place multiple times and it doesn't matter how you got here. Like let's say you rob here, for example, and then you come over here, or you don't rob both of these, right? You don't rob this one, don't rob this one, you come over here. And it's like, what's the value starting here? It's going to be the same no matter how you got here. So that's another important thing for DP is you want to think about like, does it matter how I got here? And in this case, it doesn't. As long as you're there and the house is robbable, the value should be returning is exactly the same no matter what the path you took to get here. Okay, and so that's pretty much all we're going to need to do. Just rob the house, not rob the house, simple recursion in a base case, and a caching. So let's code that up. And like I said, there is a way to do, I'm just going to code it up with memoization. There is a way to do with like bottom-up space optimized, but it's just a little bit longer. And if you are interested in that, you can check out my actual Python video on that, and it's pretty in-depth. So what we need to do is we need to make a cache. So let's do that first. So let's just say like const cache or something. And what's the type here? Well, the all right, this is wrong. The type is going to be, the key is going to be I don't know, I can't talk today. The key is going to be an index, right? So it's going to be a number. And then what's the value going to be? It's also going to be a number, right? It's going to be like the value we can get from robbing it. And so we're going to set it to this. Okay. Now we can make our DP function. So we can just say const DP. You can use better variable names, but for the sake of this stuff, I'll just use really easy ones. It's going to be a function, and it's going to take an index. That's a number. We can even take I if we want to, I guess, just to make it easier. And it's going to return a number, right? Like the value, the total value you can get from robbing. And so what's our base case here? Well, if I is greater than or equal to the numbers, then we're out of bounds, right? So if we're out of bounds, we want to probably just be returning 0, like I said, because there's nothing else to rob. So that one's pretty straightforward. Now, what's our other base case? Well, we have the cache case, right? So if object, we can do it this way, but you can also do some other stuff. Object that has own cache, and it's gonna, we're looking for the index, then we can return that as well. So return cache I. It gives you an error here because I think like this is not updated, but you can do a bunch of other stuff. This still actually runs and it's fine if you run it somewhere else. Yeah, so we would return cache I. I guess we could just like do something else if, so we could do something like this as well. Yeah, so if this is cache, we want to return that. Otherwise, we just want to maximize robbing and not robbing. So we can just say cache I equals math.max. So if we, let's start with a rob. So if we rob, we will rob that index, and we will add dp of I plus 2. And the not rob is we don't get a value, but we just go to the next index. So we get whatever's bigger there, and we return it. Cache I. Get whatever's bigger there, and then return it. And then finally, we can return here the dp of, yeah, so we can return the dp of index 0, right? So we can just do this, return. And let's check that out. Looks like it's fine. So let's take a look. Oh, we got a wrong answer, interesting. We get undefined. So I guess we missed something. That's interesting. Let's read our stuff again. So cache I, record number is fine. Const dp takes an index. Okay. If I is greater than num's length or equal to, that's fine. Return 0. That's fine. Cache I. Oh, right. This is not an array. This is this. There we go. So time-wise, these are all the same, and then there's like a space-optimized way to do this as well. Are we okay? Curious. Okay, this is our nums. Let's see what this test case is. I've actually never had it fail here before, so that's kind of interesting. So it's all zeros. Okay. It looks like we're not moving it up or something. If we got a time limit exceeded, I'm kind of curious there actually. But let's see. So our nums is just an array of like a bunch of zeros. So let's think what would happen here, actually. If cache. I wonder if it's actually because of this. Let's just check for that. Could very well be, but let's double check. Let's actually use this test case. I'm probably going to fail the same thing, but let's see. Oh, no, it was that. Okay. So, yeah, so I think that's the problem with using, like, cache I or something, is it might be somewhere else. It might be, like, in the prototype or something, and then you have issues, which is why this is, like, the safer way of doing it. So I guess that is a real-life example there. Yeah, as far as the time, it's, the time should all be the same pretty much, so it's all over the place, and then the space can be optimized, like I said, to be O1, but we're going to leave it with this one. So let's actually do the time and space here. So the time is going to be, we just have like I states, right? And once we calculate it once, they're all going to be O1. So that's just going to be the length of the num, so we'll call that OVen. And the space is also OVen because we have a cache that has indices and number. So yeah, I think that is everything for this one. So hopefully you enjoyed this one. And like I said, if you want to look more in depth for like the bottom-up DP and space optimized bottom-up DP and all that stuff, I think if you do want to start learning those, these are really good problems to practice that in, because these are kind of easy. And so it's kind of hard learning that for the harder problems. So if you do want to start learning those, I'll link the other video for those. But yeah, that's going to be all for this video. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.